Well, good morning, good afternoon, or good evening, depending on where you are in the world, and welcome to this workshop brought to you by Mayhem. My name is Cody, and welcome back to Techstrong Learning. We have an exciting workshop ahead, but before we dive into things, we have just a couple of notes I'd like to review with everyone. First of all, we are recording today's session, so if you'd like to follow along at a later time, if you'd like to rewatch, or if you'd like to share this workshop with your team, you will be receiving an email shortly after we conclude, and that email will provide a link to the recording. Now, if you would like to follow along and you have questions, comments, concerns, any issues with following along, there are a couple of ways that you can contact us. The first option is the chat tab. And just to help keep things organized today, if you have general thoughts or comments, put those in the chat tab. But if you are having issues with the workshop itself or any specific questions, we do really want you to submit those to the Q&A tab, as that will just help us facilitate communicating with you easier and helping you resolve your issue. So with that, if you jump over to the handout section, you'll see there is an automotive case study report there for you, but there's also a workshop requirements resource. And that's essentially going to be these slides that are going to help us walk through our platform today. So feel free to grab that to help you follow along. Finally, today we will be selecting 2 of our most engaged attendees to receive $50 Amazon gift cards. So be sure to take part in our workshop today, fill out our survey at the end, and all of these will qualify you for that gift card. So our program today is titled How to Bring DevSecOps to V-Shaped Development. And I'm joined today by Robert Vamosi, Security Evangelist at Mayhem. And Robert, I'm going to leave you to introduce the rest of our panel and dive us right into our program today.
Thank you, Cody. Joining us from Mayhem today, we have Josh Thorngren, VP of Product. We have Vincent Lussenberg, Director of Customer Solutions. And as Cody mentioned, I'm Robert Vamosi, CISSP. I'm Director of Product Marketing here at Mayhem. What we're going to be covering today is the automotive attack surface. We're going to talk about some common risks and some common attacks on that surface. And we're going to talk about the V-shaped DevSecOps. We're going to break at that point for some questions if you have, and then dive into the workshop itself, where we're going to talk about CWEs and achieving compliance. Now, what you'll need for the workshop, Cody mentioned, there is a link that you can go to, or you can go to app.mayhemsecurity, and there you can create an account and log in. Optionally, you can also download the CLI and create an API token if you wish. I'm going to repeat this QR code later before we go into the actual hands-on workshop, so don't worry. If you want to get started, feel free. So, cybersecurity is the top concern among automakers, and really, it's not a mystery why. The volume of code today is staggering. For example, a Boeing 787 has about 6.5 million lines of code, whereas the average vehicle on the road is around 100 million lines of code. And when we start talking about battery electric vehicles or even autonomous vehicles, we're pushing about 200 million lines of code. And it's just not the code in the vehicle that we've got to be concerned about. There's also increasing complexity with the whole vehicle ecosystem. And what I'm talking about there is the third-party software and subscriptions of services that extend beyond the physical vehicle into the cloud, into other areas. So this concern over cybersecurity by automakers, it makes a lot of sense. It's a challenging environment. First of all, we're talking about distributed systems. There are a lot of individual systems in a vehicle that have to connect and talk to each other. And again, we extend that out to the third-party systems and infotainment, and also the telematics that report up to and back from the OEMs. There's an increasing push for new features. A lot of things are being added to the ecosystem all the time. And by having software enablement, that means that you can start to add features after the vehicle has driven off the showroom floor. And with battery electric vehicles, They require additional smart charging stations, as well as in the future, V2V communications, where they'll be able to talk to another car on the road directly. Again, more software means more lines of code to secure. And then there's patching. Patching in a software-defined vehicle is getting more complex. The production happens at a massive volume when you're talking about vehicles. There's whole fleets that are being developed at once. So stopping and starting production is very costly, and it has significant impact on the OEMs. Once a vehicle has left the dealership, then it's a challenge. How do you fix it? Not everything needs to be recalled into the dealership. So there's over the air for some of that. But how do you over the air something that's a single chip in a vehicle that you're trying to fix? In other words, how do you fix hardware? As daunting as all of this may seem, we don't have to reinvent the AppSec wheel with automotive. Automotive software security isn't all niche technology that we haven't seen before. No. In fact, it turns out auto security is just application security. It's the code we already know how to handle applied to a vehicle. So at Mayhem, we have found that of the published CVEs in the mobility space, 90% of the attacks since 2020 are on the software-controlled peripherals and not necessarily on the CAN bus. The attacks are coming via the cloud, mobile apps, and other remote vectors. And they've grown 4x since 2020, as I mentioned. The good news is that 2/3 of these attacks are already covered by the OWASP top 10, and 1/3 are on the most recent SAN top 25, which means these common buffer overflows and remote executions, they should already be familiar to most developers. So we should be able to fix this. So let's take a look at the mobility attack surface. So what we really have to figure out is how to take the best of DevSecOps and start to apply it to the automotive world. This requires adapting the V-shaped development environment, which is really just a waterfall approach with traceability back on every step, to the modern DevSecOps environment. The goal is, of course, compliance with roadworthiness regulations, and also the ability to discern which component in the supply chain has failed, and therefore also know how many vehicles it affects on the road. So let's start by understanding the attack surface. At the very top level, the exposed attack surface is pretty generic. In other words, it's basically enterprise software by any other name. Talking applications, over-the-air servers, telematic servers, we're talking the cloud. This is true in ICS as well, where the top layer of the Purdue model is the business enterprise software before you actually drill down to the individual PLCs. So the off-road vehicle backend systems, along with the communications layer and the vehicle itself, these are the areas I've marked in red. That's where 90% of the automotive attacks start. It'd be simple to say that it's just the infotainment system, the IVI, but that's not true. There's also telematic systems that report diagnostics or push out navigation, and they have been targeted as well. Diving deeper, we see the connective tissue between these systems. And this is what enables attackers to chain exploits together and create mayhem. This might seem to be CAN bus, but it's not always CAN bus that's involved. You can lock out an owner, or you can create a denial of service against the owner just with a keyless entry compromise. And there's active concern about ransomware on vehicles coming in the near future. As for the CAN bus, I took a training course at Black Hat USA one year with the founder of DEF CON's Auto Hacking Village, Robert Leal. And we were seated around a bunch of ECUs. We had them on our desks to play with. And these were obviously physical attacks, of course, but we connected our laptops to them and we tried to inject commands to see how the ECUs would respond to those commands. Here is where the real damage could be done, such as disabling brakes on a vehicle, Oftentimes, we were only able to turn on and off the lights or turn up the music to full volume. In other words, fun and games. Fortunately, the CAN bus is buried deep within the vehicle. There's Ethernet connectivity, and there's also gateways that also connect the vehicle components to each other and to the outside world. Really, it's the outside world that the remote attacks are happening in today. And the challenge then is chaining together individual exploits. Again, this is something we see in the enterprise systems today as well. So it isn't just one exploit that you have to worry about. It's an attack chain of several exploits. So looking at some notable real-world attacks that are remote, we see a pivotal event occurred in 2015 when Charlie Miller and Chris Valasek successfully remotely commandeered a Jeep Cherokee driven by Wired reporter Andy Greenberg. While Greenberg was on I-70 in St. Louis during rush hour traffic, Miller and Valasek were miles away, and they were able to turn up the music inside the cabin, and then they disabled the brakes on a moving vehicle. Andy told me later that he didn't know exactly what they had planned to do, and he was lucky to drive the car off the road and into the ditch to a full stop. By the way, there's a video of this on YouTube if you want to check it out. It's scary. So is the vehicle safety in the event of a software compromise. Andy was able to take the car off the road safely. However, the flaw, it turns out, was in the Uconnect system from Harman. This was a tier 1 supplier. And what it was a vector into the infotainment system that allowed Miller and Valasek to remotely access the CAN bus without being in or around the vehicle itself. This remote hack and the subsequent recall of 1.4 million vehicles forced Fiat Chrysler Automobiles, FCA, to pay $105 million in fines to the National Highway Traffic and Safety Administration. This also sent a very clear wake-up call throughout the automotive industry. In fact, they gathered together in Auburn Hills shortly afterwards to discuss how they could approach cybersecurity full on. In 2020, Mercedes was featured at Black Hat USA 2020. Researchers used 19 vulnerabilities, of which only 6 are public. The 13 were reserved for security reasons. And they relied upon attacks going into the infotainment system and the TCU, the telemetry. This affected up to 2 million connected vehicles in China. Mercedes is credited with working with the researchers to resolve this before the presentation at Black Hat. Then, from 2021 to 2023, at CanSec West in Vancouver, there's the Pwn to Own contest. This is a clever contest where they actually put a device up and say, if you can hack into it, you own it. And it started out with laptops and tablets, and it's moved on to full-on automobiles, where Tesla has said, if you can hack our automobile, you can drive it off afterwards. Well, this happened in 21 and 23, and in 22, they didn't quite get the vehicle, but they did achieve hacking in for various other reasons. They were disqualified from getting the vehicle. But the point here is that they hacked into Tesla Model 3s using a series of remote hacks that got them closer and closer to the CAN bus. And actually, in 2023, they did something very clever in that they used a gaming technique called glitching, where they interrupted the power supply and rebooted the vehicle in order to inject their malicious code. And they basically jailbroke the commercial paid systems on a Tesla and were able to unlock the rear seat heating feature, which you would have to pay extra for if you went the usual route. So clearly there are some real world attacks that are worth paying attention to, showing that remote hacking is real. So we have to find how to secure our software. And we have to do that before the software becomes software/hardware. So let's look at that V shape again. The V model, here the V stands for verification and validation. And it splits the development process into 2 parts. The left arm of the V consists of the requirement and analysis, function design, and software development, whereas the right arm concentrates on the verification and validation activities followed by the release. So how do we DevSecOps it? Well, we have to fit testing into a place that shifts far enough left to be useful, but far enough right to still be real testing. Therefore, you should test before you get to the hardware in the loop. And again, the entry points are always usually the software. So software in the loop testing becomes necessary. We also have two ISOs. ISO 26262 is primarily concerned with the roadworthiness and safety of the vehicle. And this really focuses more on the electrical system and the redundancies there. ISO 21434, this grew out of the discussions by the OEMs following the Jeep Cherokee hack in 2015. And it's meant to focus more on the cybersecurity of the software. And this is more prescriptive in terms of software security. So you have to have testing in the software, in the software pipeline, development pipeline. This can be automated so that the machine learning can handle creating thousands of unique unit tests for safety, quality, and security of your software. And as for hardware, you can use the same testing technique with MATLAB and Simulink to perform software in the loop testing before you send it to the chip, before you send it to the hardware. And it's not just the ISO standards that you have to pay attention to. There are standards from around the world that are being rolled up into industry guidance in, for example, UN Regulation 155 and 156 for trucks. This is an annual certification that requires that testing be performed. And here, too, we see a more prescriptive stance calling out what needs to be done in order to comply with the international regulations that exist. Okay, so I've set the stage. Now we're going to take a short break. And if you have any questions, this would be a great time for that. We're going to be coming up with the live demo.
Yeah. And just to jump in, I see there was a question about V-shaped development and DevSecOps. And hey, like if we're going to sit here and say that we can DevSecOps the V, is that an oxymoron? And yeah, it's a good question. And I think one of the challenges that we hear from a lot of the organizations we work with in automotive and other sectors where there's a hardware component and a software component is a V-shaped process is required for a lot of the assurances of how the systems operate when fully integrated. And so even if some of these software pieces start to adopt more, let's call it agile style approaches, there's still a fundamental design an integrated system and then do development work and then do verification work that looks like that V. And so what that ends up meaning is it's not that DevSecOps is an oxymoron in that environment. What it is that you have to be really intentional about how and when you integrate DevSecOps tooling and practices and what you ask of teams to act on. When you're doing agile software development, your ideal philosophical state, deploying multiple times a day, releasing iterative changes, and the impact of blocking something, slowing something down becomes negligible because of the volume at which you're pushing code. With a V and with something like an automobile, you can't shut down production without significant costs and impacts. You can't block work without significant delays to other parts of the production chain. And so the challenge becomes finding the right place to put security into the development lifecycle, to put those checks, both identification and mitigation remediation, so that you're balancing speed as well as balancing security and safety. And I think one thing that used to happen a lot is the majority of the testing here was hardware in the loop. which was very expensive and required significantly more overhead from a business standpoint. How do we maintain devices? How do we emulate things? How do we package software up, ship it off, and then run our testing? And in a lot of ways, it was similar to your developer writes code, IT goes and runs on a server that we've moved away from in the pure software world. And so part of what we work with a lot of our customers on is as vehicles become, software on wheels, how do we take the best parts of modern DevSecOps practices and find the right places to integrate those? And then following by the question on shift left, it's the same principle, really. You have to shift some level of finding and fixing left. Otherwise, you're incurring the hardware testing costs. You're having to deal with production recalls and associated financial, reputational penalties. But you can't work in an environment where you're testing the software as an abstract component only, because I think anyone who runs like an SCA report just on software you're going on the web, that you're going to get a lot of noise. And in regulated environments like automotive, you can't necessarily just hand wave noise away, but addressing 500 results from an SCA report on an open source component that has no external connectivity and is buried 5 layers deep on the automotive attack surface might not be the right use of resources. And so part of the shift left challenge is knowing what to shift left, yes, but it's also knowing what not to shift left. And this is why a lot of folks I talk to in the industry have struggled from an application security standpoint, because you start talking about modernizing how you deliver software for automobiles, and people say, well, I'll just deliver software. But picking up a lot of the best practices in general software security and just asking a automotive software team to do that creates a lot of noise that then the business doesn't deem acceptable. And so where we see this being successfully done is either by folks who are kind of born in the modern software-defined vehicle era, and they are software companies that make vehicles. And so they're all aligned on the business impact, and they're all aligned on how to understand the attack surface and how to connect security and dev, reachability, exploitability, or they are being very slow and steady in what gets shifted in to existing teams and existing workflows. I think one of the mistakes that happened, when some of these attacks first came out, is everyone just said, let's go buy all the tools, let's go give them to our team. And that just created a lot of rash and friction. And Lynn, as far as practical steps, the best thing I would say is it's a conversation, and it's an alignment on what level of business impact is acceptable. Because again, we're talking production delays, we're talking recalls, we're talking things that have significant, 100 million plus impacts to a company's bottom lines. That has to be assessed at a per organization level, and teams and leaders have to be aligned on that before we can start to say what gets shifted, what are speed bumps, and what are actual blocking gates. And Rob, Vincent, feel free to jump in on other questions as well, or I will just keep going down the list. Richie, in response to what organizations need to do to identify and remediate in legacy systems and cloud-based systems, the good news is, as Rob mentioned, identification is not necessarily the hard part. A lot of the things that are on the automotive attack surface are just your normal software issues. there are tools that allow you to assess and understand those. The challenge is how those get remediated and when, because, as we were just discussing, if you just shift everything left without a care in the world, you spend so much time remediating things that may not need to be addressed in order for you to ship a safe and secure vehicle. And I think part of what has to happen here is similar to where we were some time ago with application security and DevSecOps. Some of this is making sure the security teams understand what all is there and then work with development teams to get a clear picture of attack surface. But I do think when you think about remediation really needs to be driven by testing that happens closer to a fully integrated state. And what we'll kind of walk through in a minute is how, Mayhem in particular, obviously we have a product, but how Mayhem is a tool that allows you to understand the behavior of a system as it runs, that gets you closer to that hardware and to look at integrated testing and understand not just, hey, what's present, but what's actually exploitable. Because if you can use exploitability to drive remediation efforts, you're not dealing with the amount of noise of just sheer presence of CVEs, etc.
All right. Shall we shift over to the demo? In which case, Josh, you're going to take the screen.
Yeah. And let me just drop a quick link to one of the footnotes on the slides on some news articles about Mercedes. Let me drop that off. But so let me go ahead and share. And what we're going to do here is I'm going to walk everyone through how to use Mayhem to identify exploitable vulnerabilities in commonly used components. And I'm not going to try and oh, guess what? We're going to go hack something and uncover a 0-day, but I'll take a real world automotive hack and show how Mayhem can be leveraged to understand how that package works and identify exploitable weaknesses in it and pinpoint everything that you would need from a development standpoint to say, this is what's happening and this is how the team can start addressing it. So before we get started, what I'm going to do real quick is just pop back up this slide here, what you need for the workshop. So if you want to follow along, you're welcome to. If you want to just watch me, you're welcome to do that too. And you're also welcome to reach out to us later and we can do a personalized demo or work with you on how to get started here. But we'll give everyone a moment to scan, take a look. If you have questions, if you get stuck, the team's here to help on, any places where you might get challenges along the way. So do a little countdown. Everyone's got the QR code. Everyone's typed app.mayhem.security, created an account, logged in. All right, that was my 10-second countdown. I managed to do it in my head without counting on my fingers or saying it out loud. It's a first for me, so big day. So here I am in the dashboard of Mayhem. And what I'm going to do is Mayhem, it's a platform that tests the behavior of applications. And when we think about applications, it's both the code that powers applications and the APIs that provide the connective tissue between an application or component and other things in the world. For this, what I'm going to have us all do is take a look at a hack from a few years ago where researchers were able to zero touch remotely unlock Tesla. And this was the common vulnerability from, I want to say 2019, 2020. Rob, Vincent, feel free to, gleefully correct me if I'm off base there. But what you can do is we've actually made it so that if you're on app.mayhem.security, you can just pull in from our Docker registry. And so what I've done here is for all secure, Tesla, latest. This is and I'm going to tell you this, it's a vulnerable image. Now, don't tell anyone. So this was a component that's been patched since, but this was what led to that attack. And so following along with me, for all secure, Tesla, latest. And let me add it. Now, look, I'm just going to give it a nice name. And now I'm just going to run that. I can run it for 5 minutes. I'm going to run it for 10 minutes just because I like changing settings. Now, Mayhem has a lot of different things you can do with it. It's at its core, it's a platform that combines generative AI, fuzz testing, symbolic execution to create and run thousands of behavioral tests and use the results of those to create more interesting behavioral tests that explore new pathways in your applications, that explore uncovered code, with the goal being maximize coverage and maximize identification of undesirable behaviors, crashes, security flaws, things that can be exploited by attackers. So we're not going to dive into all the different pieces today. So if I say, hey, you can measure coverage, you can do advanced levels of triage. This is all, I'm doing the web UI. As much as I love workshops where we all figure out our environment variables with CLI things, I'm not going to do that today. And it allows you to customize, hey, how do these things communicate on the network? What fuzzing engines you want to include in a run? And that, again, today, we're just running this against for all secure / Tesla latest. So what I'm going to do is I'm going to go ahead and then create project and run. And I'm fairly certain this will probably break because, I'm doing it live. But what's happening?
Just wanted to. Oh, sorry, we're interrupting each other. I just wanted to call out for you guys who just created an instance. Do note that you can't probably put the runtime higher than 5 minutes, sometimes 10 minutes, because of that you're on the free tier. Josh has a little bit more privileges than that. So if you're running into the problem there, just put it on the default and it will run just fine.
I'd like to blame the person who upgraded my account 5 minutes before this call started. I was like, oh, wow, I can change this right now. This is amazing.
Welcome.
I know. So, and actually that worked out great. Thank you, Vincent. I wouldn't say we planned it or anything, but you can see that as Mayhem is running tests, it's starting to find issues in this package. And what this does is it allows you to understand, oh, and here we go. It allows you to understand how something behaves and what's actually reachable and then exploitable on its attack surface. And so going back to some of the questions that we had earlier on, hey, how do we actually figure out what to go remediate in automotive? This isn't a laundry list of every single thing present in this package. What this is it's a list of the things that were detected as this executed. And so it shifts, if you think about that entire V-shaped process, this is fairly far right in that V. It's not once you've put things on the hardware, but it's pretty far right on the software piece because it's got the component, it's got an application, and it's saying, how is this behaving? What this allows folks developing automotive software to do is get a better understanding of behavior under numerous different conditions that are closer to real world conditions that you'll see when you're actually up and running on hardware. Because you then have defects to go tackle, you can say, let's go focus our remediation on these defects versus trying to remediate on a laundry list of 500 things that may or may not be applicable to either your attack surface or the actual running behavior of your application or the components on in the automotive. So as this continues to run, you see that Mayhem, it's generating test cases and identifying defects over time. Now, for every defect, Mayhem provides a backtrace, and Mayhem provides test cases that you can share for folks to reproduce this. And so again, part of the thing when we talk about how do you effectively shift left, or how do you effectively bring DevSecOps into a V-shaped development lifecycle, is how do we make it so that we have minimal impact on a team's ability to ship a vehicle and on an organization's ability to maintain a healthy production line. By providing this type of data and this type of information, what Mayhem does is it shortcuts the developer triage, reproduction, oh, is this a problem for me standpoint, by saying, look, when we are doing full software testing, this is present. So we know that it will continue to be present as the software runs in other environments. Let's make sure that we are remediating. Here are our test cases. Here's where to pinpoint this in my app. And we'll pause here for a second. Are there any questions? Are folks following along? Are folks enjoying my narrative instead of following along? Just want to heat check, give everyone a second to catch up. If there are things in the product where, you're trying something, it's not working, or you're, hey, what are you talking about, Josh? Can you go back and clarify anything? Anything I can clarify about what we just did here before I dive into how you can use this a little bit? All right. So what I want to show off here a little bit more of is I'm actually going to switch out of this, and now I'm going to go ahead and jump over to actually this same package run a little bit prior so that folks can see what this looks like overall. And now what you see here this is the result of a full run against that component. Now, what Rob mentioned was the rise of compliance regulations in industries like automotive, and ISO 21434, 26262, UN 155. These exist to mandate doing testing that is based on behavior and uncovering unwanted behaviors. You can call it adversarial testing, you can call it fuzz testing, you can call it penetration testing.
Uh-oh, I think Josh froze. He froze like mid-sentence, which is always fun to have a freeze frame of your face like that. So that's and we lost the screen share now as well. So now you guys just have to listen to me doing my stand-up routine. There he is. He's back. All right.
Oh, sounds like I dropped off for a second. So Vincent, I appreciate the stand-up routine. just to recap briefly, where I am in Mayhem, if you go to the run that you're looking at and click over on Test Suite, what you'll see is the test cases that Mayhem is generating. And when the run is complete, you're able to download that test suite. And what this gives you is it allows you to say to an auditor or regulator, hey, under UN 155, I'm doing the necessary types of dynamic testing, behavioral testing, adversarial testing to minimize undesirable behavior, to identify unknown vulnerabilities on my attack surface, and to give my team the artifacts they need to go mitigate and remediate those. So again, are there any questions around what we're showing off here? For folks who are following along on your own accounts, are there any blockers or challenges you're facing right now, or anything we as a team can help with it? Okay. Well, what we'll do is we'll pop back into the Q&A, and then I'll actually hand it off to Vincent to show off another example of this that you can follow along with as well. And so, Vincent, I'll give you a moment to set up by answering some of the questions, and of course, rely on you for your stand-up routine when I get cut off again.
There we go.
So Qasim says, I'm assuming this meant is V-shaped meaning verify? And Rob, I think you defined what the V meant, and yeah. I know that I'm going to make something up, so I'm going to ask you to respond to that one.
The V model is generally understood to be verification and validation. That's what the V in the V model stands for. So we are on the verification and validation side, the right-hand side of the V, just before release.
Awesome. Thanks, Rob. Mike, to your question, can Mayhem be used in a non-automotive industry like regular software development? So what I actually just walked through was pulling an image down from our Docker Hub account and running it. Mayhem works in any sort of development environment. The easiest way to get started with Mayhem is by running it against a containerized image. There are more complex ways you can feed Mayhem information about what your application is that help it get started faster and find interesting things faster. But yeah, we largely work with organizations that have compliance needs and that have large teams and large production scales where they need to minimize the cost of testing, but maximize the results of those testing and verification cycles. But it's applicable, and we have customers across a number of different industries as well. Financial services, infrastructure, et cetera.
So Josh, I'd like to point out we actually have two features, one focusing on code, which you've demonstrated. We also can handle APIs, so we can point at an endpoint and give you information about your endpoints on your APIs.
Yeah. And then, awesome, thanks, Rob. And then Umesh, you asked a couple questions, and so let me break those down. Like, one, can I provide some specific examples and data points that illustrate the reduction in resources and manual tests? And the second is, has the adoption of Mayhem led to noticeable improvement in identifying and addressing? I'm going to give you a pretty direct answer on the first, which is we have a few customer stories where what they're able to do is save 7 figures plus in testing costs because Mayhem allows more shift away from hardware in the loop to software in the loop and reduces the amount of delays in the production cycle. At the same time, from the testing that we do internally, Mayhem coverage when compared to just traditional unit test or functional integration test coverage typically jumps about 20% on top of what you already have. Now, again, that's an average number. Some of that may vary, and that's our benchmarks, not an aggregate of all our customer data. We don't collect that type of stuff from our customers. I'd be happy to share more additional resources, or you can reach out to the team and we can walk through some customer stories and some of the key results there. But, it's the type of thing where you're going to see more improvement the larger the team complexity of your testing requirements are. Smaller teams that don't have as complicated requirements typically get a little less benefit out of it. And then to the question on a noticeable improvement in identifying and addressing security vulnerabilities, most of our customers who have integrated Mayhem into their development processes use Mayhem as the thing that drives remediation. And what I mean by that is when Mayhem finds an issue, it opens a ticket for a developer to go tackle. And I say that because if I think about how our dev team works, I think about how a lot of teams across industries, not just automotive, work. You don't start by opening a ticket for every single issue. You start by asking developers to go triage a list of issues. We see an improvement in MTTR, and we see a increased fix rate across our customer base with Mayhem. Now, in a few weeks, we're going to release a report on automotive attacks and how they've developed over time. I don't want to spoil too much of that, but one of the things that you'll see us talk about is a little bit of a disconnect, and this is true in several industries, but a little bit of a disconnect between publicly demonstrated attacks and vulnerabilities and CVEs. In a number of industries, there are different actions required if something is a CVE or a known vulnerability versus someone somewhere found a weakness and can exploit it. Different actions have to happen, different levers have to be pulled, different stops, slowdowns, patches have to occur. And so when I think about the broader picture of like, hey, are we able to say, well, once companies adopt Mayhem, they, have 5 less public CVEs disclosed a year or something like that. Like, we're not. Some of that is just a industry specific thing where, again, we have to be careful about how we balance security actions against business objectives. I realize I'm hand waving that question a little bit, but it is the reality of industry today.
So a good example is the Mercedes example that I cited, in which the 19 vulnerabilities that were teased in the article were actually 6 publicly disclosed and 13 that were withheld for security reasons by Mercedes.
Well, if there aren't any other questions, then we'll jump back into an overview from Vincent on another example with Mayhem that you can follow along with too. And Vincent, I believe you might be muted.
Let's press that unmute button a little harder. All right. So I'm going to actually showcase a couple of things beyond the UI as well. So because this is a workshop, I do invite everybody to follow along. So what we'll do is, in addition to logging on to app.mayhem.security with the account you've just created, you have the ability to download a CLI as well. So in this case, we're going to use Mayhem, and we're going to interact with code targets. So depending if you're on Linux, Mac, or Windows, you can download a package here and you can install. Right? I know for the Windows download, look for that UAC pop-up. It's sometimes a little bit hidden if you think that the wizard is not doing anything. Once you've installed that, and I have a terminal, of course, I prepared myself, so I've already got Mayhem running here. You can create a token here by clicking Create Token. And then basically all you really have to do is type in mayhem, log in, and then type in that token. So in this case, this is the default. So you don't even have to type that in. So mayhem, log in, and then the token that you've just created. So that would be mayhem login token. So of course, I've already done that. So what that does is allows me to locally work with code and actually move that to mayhem. We do that in the form of Docker containers. So in this case, what I'm going to showcase, and I believe this is part of the instructions as well, that we either beforehand share or afterwards share. But what we need to do in this case first is get the source code that we're going to work on. So in this case, I am going to download the AT-FTP source code and extract it so that we can actually build a Docker container. So we have a Docker file here. And what I can very simply do is Docker build, and it will basically build the source code for me. So what that will produce is a Docker container. I'm sure that lots of people on the call are familiar with that. And that is the primary way that we ship runnable running code to Mayhem. So we can just package that up in a Docker container. We can send it along, and that's what Mayhem can download and can execute and insert or analyzers into. Of course, to make it a little bit easier on everyone, you don't actually have to run this entire Docker container. It's an interesting process to go through to see how that would work. But it's really just building the software that we're going to test. What we're going to do next is what Josh did from the user interface. We'll do interactively or from the command line now. We'll create a Mayhem file that I will quickly paste in the chat, which is also part of the handout, I believe. So this contains all the instructions, all the things that Josh basically did through the UI, but you can embed that in a file and you can check that into source control as well. So in this case, all I have to do is mayhem run and then dot, pointing to the current directory. And what it will actually do is it will go ahead and it will use actually a pre-built image that's we already uploaded. Again, just like the Tesla image, we know that to be vulnerable. And we're going to instruct Mayhem using the account that I just logged in with to run a test with that. So what we will see is that it created a run for me. So now we can switch back to the web environment. In this case, I'm in my own workspace here. If I then click on runs, what I will see is that a new run just started for that Docker container that was just created. And this is very familiar. This is basically the same overview that Josh showed you previously. So what we'll see now is that Mayhem is going to download that Docker container, inject the analyzers, and it's just as for the Tesla example, what it's going to try to do is find defects. Of course, this is going to take some time. So I'm actually going to back to my original run that I already ran so that we have results. So we see examples here again of problems that Mayhem found. So in this situation, actually, to find the 0 day that we're looking for here, you would have to run it a little bit longer. Sometimes, the algorithm requires a little bit of time to find that. But the defects that were found, I can just open them up to showcase them in exactly the same way. So what we will see is multiple test cases that trigger the same problem. And what we can see here is an exact reproduction case that we get. So this is one of the advantages that we call 0 false positives. Whenever we find something, we also always supply a test case file that you can download. I can actually showcase here as well how it looks. I can download that and I can run it against my local version of AT-FTP to reproduce this exact problem, which in this case is the use of an uninitialized variable that can cause a problem. So basically, that's the same flow that you've seen before, only now I've shown you, okay, where's the Mayhem CLI manager? How can I work with code that I'm building locally? Maybe it's not code that is uploaded to Docker just yet. So even if I'm a developer, I'm working on code, I can very easily put that in a Docker image, push that to Mayhem, and Mayhem can just work on that exactly as a Docker image that's already published. Since we just have 5 minutes left, I'm just going to leave it there. Going to see if there's any more questions to ask or to answer here. Yeah, so I'll leave that there. Cool. And I just got alerted we actually have 35 minutes left. Shows you how good I am at timekeeping. I thought we were already over an hour in, but hey. Let's see. Q&A. Can Mayhem be used in non-automotive industry like regulated software development? Oh yes, absolutely. So of course the focus of this webinar is on automotive right now because we want to show this particular vertical. But we do lots of work in medical devices space as well. Financial organizations use this as well for both code and for API. Aerospace, federal government. So any organization that runs code, really, that compiles and runs code that is mission critical, or APIs for that matter, can use Mayhem. So there's not really like a limitation based on vertical or space. So I hope that's
and hopefully
answer.
Hopefully I'm back at this point too. This is and Vince, I'm going to take over on this next one just because I spent most of your demo, and I shudder to admit this, but I spent most of your demo writing a very nice long response to Umesh that I was going to post before you finished, but then I got booted from the webinar. So Umesh, to answer your question about what the long-term plans for utilizing Mayhem are, philosophically, like you ask any of us on this call, we're going to tell you DevSecOps and shifting things left to developers has been a very noisy approach that has created a lot of thrash, a lot of what do I go tackle first, a lot of slowdowns. And look, the reason we're still proponents of shifting things left is it's better than the alternative. It's better than finding and fixing everything when it's in production, when you're testing on hardware. But for us, we want to make sure that developers are focusing security remediation efforts on what's reachable and what's exploitable. What we walked through today was Mayhem understanding the behavior of applications to understand what's exploitable. And you might say, well, doesn't that imply it's reachable too? Yeah, no, that's realistic. But what we're really showing is how are these things exploitable and pinpointing where you need to go take action. What's coming in the next 12 months from a platform perspective is extending our functionality to use Mayhem's technology to answer the reachable question, to take the results that you get from a SBOM or SCA tool, something like that, and say, okay, based on analyzing how this application runs, what components are on the attack surface? And then marrying together that reachability analysis with the exploitability analysis that you saw today to give developers an easy way to say, out of all the components I use, here are the ones on the attack surface, here are the ways in which they can be exploited. And from that, it gives security a accurate risk picture that they can communicate. And it gives developers an accurate risk picture with the information necessary to go remediate and not spend time wasted on doing the reachability, exploitability, is this a false positive analysis themselves, which is where we see much of the slowdown. So that's where we're going from a roadmap perspective, while continuing to, build out the fun, interesting secret sauce, AI, ML, whatever you want to call it, where cybersecurity is a real buzzword, but essentially portfolio of algorithmic approaches that does behavioral testing. And then around, do we assist with vulnerability solutions or do we just notify?
I can take that.
Go for it.
Yep. Okay. So we kind of do both, right? So we highlight what the vulnerability is, and where we assist in fixing it is by linking to common CWEs as well. So it shows what the underlying generic problem is. Like, for example, if it's an uninitialized variable or a buffer underflow or overflow, it immediately links the developer, in this case, to resources on what is this problem? What does it actually mean? Because a lot of these things are pretty jargony. It's not that we are generating like sort of a diff that that you can just apply to fix it, so that we're not generating code for that. Although I do like to underline is the original version from Mayhem, which was a research project. The original version of Mayhem was actually able to detect exploits, patch them automatically, and actually weaponize them as well. So it's not a limitation of the technology. It's something
we were asked very nicely to take it out of the commercial product.
That's correct. Yeah. Yeah. Also has something to do with that sort of customers in our space probably wouldn't really like us if we like patch something on the fly, and then you have some unknown binary that maybe works or maybe doesn't. Although we tested as well in the challenge that we did with Mayhem, like testing that our fix actually worked was part of what we delivered, but something that doesn't really port that much to the commercial version. So long story short, we empower the developer with knowledge about what the underlying common weakness is, so that they can understand better what's going on. We give them the exact register state, memory contents, exact backtrace where the problem occurred. Insofar we can determine that. And the most important thing is, in an assist of a developer, is having that reproduction case, right? Because imagine if I'm a developer for ATFTP and I just have it running on my local machine, but I have all my debuggers attached, and I have that reproduction case that I can just execute then I can trigger that exploit while all my debuggers are running. I can see exactly what's going on right there in my local environment. Then I can do some fixes that I think will fix the problem, write a test for it, etc., etc. And then I can execute that reproduction case again to verify that the problem indeed was solved. So we generate sort of the test case for you. So those are some of the major ways that I would say that Mayhem helps developers actually fix the problem. So hope that's a satisfactory answer for you there.
Is that it? Are we good? Are there other questions? Well, hey, thank you all. For those of you who did follow along, hopefully you got to see Mayhem in action. Hopefully you're like me, and once you got in the products, mostly ignored what we were saying, got to click around, do some things super relevant to your day-to-day or workflow. Feel free to reach out to us if you want a customized demo or you want a little more information about Mayhem, what it does, what the roadmap is, and how we help some of our customers today. And yeah, really appreciate everyone's time, questions, and engagement. Thank you so much.
Awesome. So any questions that we received today, all of our chats, we are going to be sure to send those over to the folks at Mayhem, mostly here to the speakers. So they'll be able to look at your questions and hopefully send you a response afterwards if they weren't able to answer your question up front. So Vincent, Robert, and Josh, thank you all so much for your time today.
You bet. Happy to have been
Thank
here.
you. Thank you. Really appreciate it.
All right, so a couple more closing remarks for our audience. Just a reminder that we have been recording our workshop today, and you will receive that recording here shortly via email. You'll also find it living on the DevOps website. That's devops.com/webinars. The two winners of our $50 Amazon gift card drawing will be contacted here shortly. So if you were able to engage with us today or submit a survey, those are qualifying. Those will qualify you for the gift card. So be sure to do that before you leave. I'd like to thank Mayhem for sponsoring our program today. And to everyone who's attended, followed along, thank you so much for being here today. We appreciate your time, and we do hope to see you at a future Techstrong learning experience. Have a great rest of your day, and you may now disconnect. Thanks again to Vincent, Robert, and Josh. Really appreciate it, guys.
See you all. Thank you. Happy holidays.